Please note that this webinar will be recorded and it will be made available afterwards on the iCargo website. The webinar is part of the iCargo training series, and in this series we would like to share with you how you can use and adopt the various concepts developed in the EU FP7 iCargo project. Now some of the webinars are more into the logistics operations supported by iCargo. Some others are about the technical concepts developed in iCargo, and this webinar will go into the second part of that. So I'm not alone here today. My name is Matthijs Punter. I'm joined here today by Laura Daniele and Maarten Steen. We all work for TNO, which is an R&D company in the Netherlands, and we are one of the partners in the iCargo project. We are doing research on large-scale interoperability in logistics, and in today's training we would like to show you how you can build intelligent cargo solutions using semantic web technology. Today's agenda has three key parts. First of all, I would like to start off with an introduction. What are iCargo solutions and how do they look like? And what can you do with them? Secondly, my colleague Laura Daniele will take over to discuss with you the logistics core ontology, which is a semantic model you can use to configure so-called access points. More about that later. And finally, Maarten Steen will demonstrate you how to develop a semantic web access point. And we have a real-life use case that we will demonstrate there. We'll close the session with some conclusions, and afterwards there's the possibility to ask questions in a Q&A session. So, starting off with an introduction. First of all, what is iCargo about? For those of you who are not familiar with iCargo, as indicated, it's an EU R&D project, and basically it looks at three things. It looks at introducing new logistics services in the business ecosystem, a range of new logistics innovations that iCargo looks at, for example, to synchronize vehicle movements, to look at dynamic planning of the logistic chain, adapt faster to changing conditions, combine services, monitor emissions. It's also a very important aspect, because iCargo is not just about optimizing your logistic chain from a supply chain and financial perspective, but we are also looking at the emissions, especially carbon emissions of the logistic chain. Now, if you want to introduce these logistic services, you need to have intelligent cargo solutions, IT or information products that support the introduction of these new services. So in iCargo, we're developing a range of these solutions for monitoring your logistic services, for chain planning, for CO2 calculation, etc. Other webinars in this series will go in more detail about these iCargo solutions. And finally, you need to have an information architecture that facilitates the data exchange and the collaboration in the business ecosystem. So you need to have the IT in place for these intelligent cargo solutions. These are the three topics that iCargo as a project is looking at. Now, that's all quite conceptual. Let's just look at an example of such an iCargo solution. This is a demonstration case. We call it Truckers United. And to give you a bit of context about this solution, the context is a container terminal, dealing obviously with containers, and a collective of about 150 independent truck operators that deliver containers at this terminal and that come to this terminal to pick up these containers. They're independent from each other because they're separate organizations. On the other hand, they depend on each other because they have some shared objectives. Both want to reduce the turnaround time of these trucks at the terminal. From a truck perspective, they would like to plan their operation more easily, so they maybe arrive at the terminal at off-peak hours, so they have reduced the turnaround time, and they can decide whether or not to go to the terminal at a certain point in time, depending on the traffic at that moment at the terminal. And on the other hand, there are also the terminal planners that want to optimize their operations. So they need to know about the trucks. When are they coming? Which container will they pick up or will they deliver there? So they can also optimize their operations at the terminal. Now let's assume this example case, and let's assume that our goal is to build a tool that supports this type of dynamic planning. Well, first of all, how could such a tool look like? Well, this is a mock-up of such a tool, but what you can see, maybe you want to see on the map and visualize where the trucks are that are getting to the terminal. For those of you not familiar, this is the Netherlands, and here's the port of Rotterdam. So probably the container terminal is somewhere there in the port of Rotterdam, and it wants to know which trucks are heading for the terminal. Maybe to see how many arrivals and departures there will be over time. And from a truck planner perspective, you might want to know, okay, if I arrive here at 4 o'clock, what is the estimated turnaround time here at the terminal based on the situation there at that point in time? And maybe they also want to know a bit about the traffic conditions to and from the terminal. So if you want to build such a solution, you need to have a lot of data. You need to have data about terminal operations. Probably that's available somewhere in the system of the terminal. But you also need to know where are all these trucks. There are a lot of them. They're independent, and you need to have data on their vehicle movements. And finally, you would like to integrate some real-time data on traffic conditions to assess, for example, what the travel time is to the terminal at a certain point in time. Now, let's assume that this is the type of solution that we would like to build. Then, if you start off doing this, there are quite a number of challenges that you need to overcome. First of all, there's a large number of organizations that you need to connect. Data is all over the place, and there are large numbers of systems, and you need to interconnect them. Probably, because they're independent organizations, they will use different technologies for collecting and for sharing data. It's likely that their semantics are also different. For example, how do they describe a location? That can be different. Some will hard code it, some will use just the address, and others will use coordinates. So there are differences in semantics, in the meaning of data, and you need to deal with that when you're building such a solution. So things can become complicated quite fast, because at the same time, from a business case perspective, we want to have a speedy development at low costs. And we also want to have a system that is future-proof, because we can do this integration once, but maybe we want to reuse that at a later time for another intelligent cargo solution. So iCargo tries to solve this through the concept of an access point. And in the vision of iCargo, every organization could have an access point to share data with other organizations. Now, what is an access point? It's a software component, might be a cloud service. The idea is to deploy such an access point only once, and then when you've deployed that, it provides you with connectivity with every other access point in your business community. It provides you with secure and controlled data sharing, and in the end, it provides the required data for your iCargo solution. So it's like an email server. You deploy it once and you use it to communicate with everybody else who has an email server. Now, in iCargo, we implemented this concept of an access point, and today there are numerous vendors of such an access point. For example, Atos, Inlecom, and CGI, who are also partner in the iCargo project. We use 3 distinct types of technologies to implement access points. First of all, we have a very traditional access point based on traditional XML message exchange and web services. We call it the eFreight access point. And it's used today quite a lot in port community systems and so on. And probably most of you are familiar with that. But we went beyond that. We also implemented an access point using a simplified REST API. This is new in iCargo. We are using this in our pilots because it facilitates the integration with, for example, mobile apps, which can be difficult when you're using large and complex XML messages and web services. But on top of that, we also looked at semantic web technology. As some of you might be aware, semantic web technology, that's new technology from the IT domain. It has some specific advantages. We will take a look at that. And we said, okay, building on top of what is there, can we also implement an access point based on that new technology? So we have a technological demonstrator for that. It also supports the use of linked data, and this third type of access point is the focus of this webinar today. What I'd like to point out, however, is that all these access points are interoperable. So we looked at the full tooling suite and said, okay, maybe you want to develop a REST API on top of this new semantic web technology access point. And similarly, we provide gateways, for example, to connect traditional message exchange systems with the more simplified REST API as it is developed in iCargo. But we have some other webinars that go into that in more detail. Today we will focus at the iCargo access point using semantic web technology. So before I hand over, let's assume that you you've installed your access point. Then what do you need to do? First of all, you need to configure your access point, specifying the semantic model of your organization. Basically, what you need to do is to specify, okay, I'm this type of organization and I would like to share data about these type of objects. So, for example, in the Truckers United case that I introduced, I'm a truck operator and I would like to share data about trucks and their locations. Now, we support this type of configuration using a logistics core ontology, and in the second part of this presentation, Laura Daniele will go into that in more detail. And then secondly, obviously, you also need to feed your access point with data. So you need to set up connections with existing legacy databases, for example, or mobile sensors or mobile access points. And we support both in iCargo, and my colleague Maarten Steen will go into more detail about that. So first of all, I would like to hand over to Laura, and she'll discuss with you how you can configure your access point using a semantic model, and especially with the logistics core ontology. So Laura, I'll hand it over to you.
Thanks, Matthijs, and good morning, everybody. I am Laura Daniele, and my role within iCargo and in the TNO team was to develop and maintain the logistics core ontology that Matthijs was talking about. So today in this presentation, I'm going to tell you something about the logistics core ontology, which is called LogiCO. So I'm going to say what is LogiCO, how does it look like. So I'm going to show you this model briefly to give you an idea. I'm going to tell you also how to use it and what should be used for. So we have some use cases that we selected for the usage of LogiCO. And then I'm going also to tell you why LogiCO. So how is LogiCO enabling this semantic interoperability in the iCargo ecosystem, and how is doing it better than other existing solutions? So let's start now. And if we have to define logistics, well, most of the practitioners in the logistics domain make it very easy. There is a very simple solution. They always tell you, you have to transport something from A to B. But okay, we can elaborate a little bit more on that. And we start from this definition of logistics. So we regard logistics as the set of activities that take place among several actors in order to deliver certain products at the right time, right place, and under the right conditions by using suitable resources. So already here we see some core concepts, main concepts that possibly a lot, most, or probably all organizations in logistics would agree upon, because at the end of the day, logistics is about these concepts. So that's why the idea of LogiCO. LogiCO is an ontology, a semantic model, a data model that allows to specify what are the main concepts adopted in the logistics domain. And these main concepts, once again, are concepts like activity, actor, product, time, place, conditions, resources. Now, the approach of LogiCO doesn't aim at having one single common ontology for all possible applications in logistics, because that wouldn't be feasible, wouldn't be flexible, wouldn't even be possible probably. So the idea is that LogiCO has some core concepts, but we have to stop at a certain point, because not everything is a core concept, is a main concept. But then what we want to develop and what we want to have and to offer is a network of ontology that is based on some common agreed concepts, which are the one defined first in LogiCO. So not one single ontology, but then several ontologies that are connected to each other. There is always a link between these ontologies in the network. And they are extendable and adaptable for specific uses. So in case something is not there, that's not a problem. We can define a new concept and have a new ontology in this network. So as an example of this, the logistics service ontology called LogiServe is an extension of LogiCO. And that extension is used to model business activities, such as transport, transshipment, load, discharge, and so on, with their properties in order to specify logistics services. So this means that if we have an activity in LogiCO, because activity is a core concept of LogiCO, then the service ontology is going to specialize this concept of activity with all the properties and the concepts that are necessary for that. So now let's go further. And these are the core concepts of LogiCO. So this is an excerpt of LogiCO, so don't get scared because you see a lot in here. We are not going to see everything into details. Then you can check later LogiCO and you can always come back with questions. But this is just to show you how LogiCO looks like. It's an ontology, so you have classes there, and those classes correspond to concepts. Then there are relations between these classes, and there are some properties and axioms that you can define for each of these classes. So as we said before, what is logistics? Logistics is about activities. So here you see the concept of activity. There is one concept in LogiCO dedicated to describe an activity. Then we have activities that happens between actors. So we have dedicated concepts to define what an actor is and what are the property of an actor. Then we have that actors then exchange certain products. So we have some concept dedicated for that in LogiCO. At a certain place, from an origin to a destination. So of course we have a concept for place to define the different locations using addresses, or using, as Matteo said before, for example, the coordinates of a place. So LogiCO allows also to describe these type of things. Then under certain conditions, so there are certain properties, certain attributes in the model in LogiCO that allows to define certain conditions, whether something should be transported with a certain temperature and these type of things. And using suitable resources, and resources can be trucks, can be transport means, can be containers, packages. All these is a resource, and LogiCO allows you to define these. So this is how LogiCO looks like. And what should we use LogiCO for? Well, first of all, what we've seen is an ontology, and it's a schema. It's a schema that has these core concepts that should be used to create data. So what we mean is that, okay, if we have a schema, if we have how the semantics should it be, but we don't have data, that's not very useful. On the other way, on the other hand, if we have only data, we have a lot of data, but we don't know what they mean, how to connect them, and that's also not useful. So, of course, the best and how it should be is to have data that explain what happens in reality that is based on a good, consistent, solid semantic model like LogiCO. So the first use case is create instances of LogiCO. So LogiCO has the concepts, but then we create instances that correspond to real things, instances of things in real life. And for example, an instance is a movable equipment of type container. So this means that we have a container with a specific ID, 1, 2, 3, and size, 20 feet, for example, which contains a certain type of products, maybe perishable, and then it's fresh agricultural product, which is then packaged in some packages, for example, in boxes, we can say the number, and so on. And this can be moved by truck with a certain license plate. So this is very important. And anyways, we will see later some examples with Martin about instances. So we will come back to this later. So the case we were talking about was how to extend LogiCO, but that means that we take one concept of LogiCO and we specialize it, adding more concepts, more attributes and more properties if necessary. Then we have a third use case, which is, well, we have access point, we are an organization, then we have an access point, and we have, or we want to create a semantic model for our access point. So in that case, we can use LogiCO or a subset of concepts of LogiCO, since there are a lot of concepts that might be not necessary for our case. And then we can create a semantic model for that. This means that by construction, then the access point and therefore the organization will be interoperable with the rest of the iCargo ecosystem, because it's based on a model that it's shared, is used within the ecosystem to express the semantics. We will see this better later in this presentation today. And the last case is, sometimes we derive a new semantic model from LogiCO, but sometimes we want to map a model. So if an organization with an access point has already a semantic model or wants to create a semantic model independently from anything else, okay, that's also perfectly fine. But then we need to, if then this organization wants to become interoperable within the cargo ecosystem, needs to map its model to LogiCO. We have tried this several times, and it's usually quite straightforward to map a semantic model into LogiCO. So in this case, the semantic model is not interoperable by default, but it becomes interoperable in the moment a mapping to LogiCO is provided. Now, what are we going to solve? What's the problem we are going to solve with all of this and with LogiCO? So let's take the case of semantic interoperability without LogiCO. In this case, we have two actors. For example, a logistics service client, which is a consigliere of fresh agricultural products, for example. And then we have a freight service integrator, that is the company that is then going to arrange the cargo's transportation on behalf of this logistics service client. So the traditional scenario is that these two different organizations and actors in the logistics domain want to interact with each other. And then one is talking about fresh agricultural products because that's what they are providing, right? And the other one is not really interested anymore in what's the specific type of product as long as it is transported properly. So the type of terminology then it becomes talks about cargo. So this means that there are two semantic models here. One that is based on fresh agricultural products and one that is based about cargo. But what's the link? How to make this interoperable? And for doing that, we need to map these two semantic models. So we need to find the links and say explicitly how fresh agricultural products relate to cargo, if they are different or if they are the same. So we need to create mappings. So far it doesn't seem to be a big problem, but the problem comes when we have a lot of organization, because they might need then to interoperate with each other with more than one other organization. So there are a lot of organizations, a lot of access points, and a lot of semantic model. So if we want all of them to be able to interoperate with each other, with all the other access points, with different semantic models in the iCargo ecosystem, obviously there is a problem. So this solution means so many mappings, create dedicated mappings and correspondence. So this becomes impossible to handle. That's why we want to create semantic interoperability with LogiCO. So what does it change then? With LogiCO, we have then the same case as before. So we have the two semantic models as before. But now we do not want to create a dedicated mapping between these two semantic models, but we want to use LogiCO. So far doesn't seem to be actually helping too much, because it seems like, yes, we are introducing actually a third model why we should do it. But it's going to be clear in the moment we come to the picture that we used before, because then we do not want this situation, but we envision a different situation, which is this one, in which we have all the access points with their own models. There is LogiCO, so in this case there is LogiCO and in general the logistics network of ontologies, LogiCO, Logiserve, and all of the other possible extensions that can be created. And then the only thing needs to be done is create only one set of mappings of each semantic model to LogiCO. So in this way, we create interoperability in a nice, easy, and nice way, because in this case, we create only one set of mapping. Coming back to the case that we said before, so this picture helps to understand that in the first case, we had, so if we have this access point with this semantic model 1, the first case is that the semantic model is not yet there. So we take the semantic model and we create it out of LogiCO, and we are by construction interoperable with this. Otherwise, we create the semantic model and later on we create a mapping to LogiCO, and we become, the access point becomes interoperable with this. So just to conclude, where can you find these ontologies? Well, we can find them on the ontology server. So you can find the turtle file extension, which is it's probably loading. I hope it will still be there. So it's very easy. So then when you click on the link, you just save it. And otherwise, there is the other link which provides you with the documentation, and then you can click on it. You can see what happens in a nice interactive way with the different things. With this, I am done for today. Thank you very much, and I give the word to Martin.
Okay, good morning, everybody. My name is Martin Steen. And I will take over from here. So in this final part, I will talk you through the more practical side of creating your own iCargo access point using standard off-the-shelf semantic web technology. And so first, I probably should start to explain what we mean by a semantic web access point. So the concept of access points was explained in the introduction by Matthijs, and the iCargo project has produced a number of specifications for access points, so that allows you to create your own access points. Yeah, obviously creating your own software implementations can be quite, especially for such complex specifications, can be quite hard. So we explored an alternative way of creating access points, which is the semantic web using semantic web standards, because the whole idea behind these access points is that they provide a uniform interface to logistics information, and that they enable the meaningful exchange of this information by annotating it with by annotating the data with semantic models. And this is actually very similar to the objectives of the semantic web and the linked data initiatives of the World Wide Web Consortium, the W3C. And therefore we show in this webinar how you can establish access points by leveraging semantic web standards and off-the-shelf semantic web technology. So this table here lists some of the semantic web standards that we use. The resource description framework, uniform data model for the semantic web, uniform resource identifiers, a way of identifying and locating data entities on the web, that's uniform. The web ontology language, actually we've already seen an example of that, because expressing from relational data, which I'll show in a minute. It's very useful for connecting legacy systems to your access point. And Sparkle, the query language for the semantic web. So these are some of the steps I will take you through to create an access point. Firstly, I'll say a bit more about this Truckers United case. Then we'll create a semantic model for it and a URI scheme. I'll explain you the technical architecture for a semantic web access point and which technology components you need for it. We'll talk about connecting a legacy system. Then I'll show you how you can manage the access point through our web interface. And finally, how to expose the data through this access point for other access points and applications to use. Okay, so this Truckers United case, Matthijs already briefly explained it. So we're assuming here there's a collective of road transport companies, and they currently have a database-backed system with planning and trip data. And so now they want to participate in the iCargo ecosystem, and therefore they have to set up or establish an iCargo access point so they can manage this data and share it with the community. And for example, their data has to be combined, and so they need to interact with data that is provided by the container terminal. And so the container terminal might have their own access point. So here I will talk you through the steps that Truckers United has to take in order to set up an access point using semantic web technology. Just as a reminder, here's again the picture of the case, illustrating the kind of system that we would like to realize, showing where the trucks are and when they are arriving to the terminal. So if we look at the current system at Truckers United, it's a database system. So in this database we find several tables containing data. Here's just a small example of a truck info table, some table that contains information about the trucks of the respective companies in this collective. And so we see things like the identifiers of the trucks, the owner, the company that owns the trucks. We also see location data, so where are the trucks currently? So this table is fed by the communication from the onboard systems in the trucks. And so we can also see, for example, the fuel levels of the trucks in real time. And the truck drivers can also indicate what kind of activity they are currently engaged in. So this data is maintained in a quite standard Postgres database. And so this is the current situation, if you like. So what we need to start with is create a semantic model, like Laura explained. You have to create a semantic model to expose the data, to describe the data. And so in this case, we came up with a small ontology using a tool called Top Rate Composer. and this illustrates that in this ontology we find concepts like a truck and an organization and a driver, and also a geoposition, for example. And these concepts, these classes, they have different properties. Some of these properties are relationships with other classes, other concepts, and some of these are so-called data properties, so they indicate some data value. So this kind of model can be created by the company itself or by some supporting IT company. And now, in order to make this model interoperable with the iCargo ecosystem, of course, like Laura explained, we have to relate it to LogiCO. And so here in this image, we see at the bottom the truckers ontology, so the ontology we just created, and at the top we see some of the concepts in the LogiCO and LogiServe ontologies, and we can draw relationships between these ontologies also in a tool like Top-Rate Composer. You can specify which concepts in LogiCO are specialized by our truckers concepts or truckers ontology. So, for example, the concept of actor is quite a general concept. In LogiCO is specialized in two different ways in the truckers ontology, namely to a driver. A driver is a kind of actor, but also an organization is a kind of actor. Other concepts like truck, they appear directly in LogiCO, so we might as well have used directly the LogiCO concept. So this is necessary for enabling interoperability with other access points in the ecosystem. Secondly, we need to define a URI scheme for identifying the entities in our access point. The URI scheme is an identification scheme, a naming scheme. And here in the first line we see the type of scheme we're using. We're following the we're using best practices for publishing linked data, which dictate that URLs should be used as URIs for linked data. This means that the identifier is not only an identifier, it's also a URL which you can, for example, insert in your browser to find out more information about this entity. And as an example, as an example here, so first of all, we have a domain, so the server name where the access point is hosted, and the name of the access point in case we want to host multiple access points at the same server. Then to indicate that it's an identifier, we have the ID. Then the thing itself, so in this example, a container with number 1, 2, 3 is identified by its type. We're saying it's a container, and then a unique identifier within the set of containers. So container number or a truck number, a truck identification number, it can be used. Concepts themselves are also named. So the ontology itself, the truckers ontology, is found it is named in this way. So this is a generic schema for naming ontology concepts. And so the truckers ontology itself is found here. The access point for Truckers United can be found here. This is a server that we set up for experimentation purposes. And so below this URL you find then all the entities in this Truckers United access point. Okay, I'll move on to the technical architecture, the technical components. So the nice thing about using standards is that there are several implementations of these standards, so we can take some off-the-shelf semantic web technology to build up our access point. And in this case, we have opted for the Virtuoso open source linked data solution, which consists of an RDF triple store, where we can store the data as linked data, an inference engine can use to reason, and a Sparkle endpoint to fire the queries at to have an interface for queries. And on top of that, we're using a product called ontowiki, which provide a nice wiki-like environment for browsing and managing the data, as well as a simple API for other applications and access points to connect. Now, since we do not expect that existing back-office systems work with RDF data, linked data, we have also installed a stack of technology for extracting data from legacy systems. Here we assume that the data is stored in some traditional relational database, and then on top of that we have installed something called OnTop Quest, which provides a reasoner for translating Sparkle queries to the normal SQL queries on databases. And then OpenRDF Sesame provides an API for accessing this data in this way, as if it was linked data. So, if we want to connect a legacy system, of course we have to provide some kind of mappings between the structure of the database and the ontology we've just created. And here at the conceptual level, this looks more or less like this. So we just say that the concept of truck is somehow related to this table truck info, and this truck concept has several properties. It has to have a name, a URI, has a property of driver, a license number, owner, etc. And so we have to provide mappings to columns in the table. This can be one-to-one, but also sometimes we introduce new concepts like the geoposition is a separate concept in the ontology with latitude and longitude properties, whereas in the table we just have the latitude longitude properties as columns in the table. Now this is the conceptual mapping. After you've made this, you have to formalize it in R2RML or something similar. In this case, we used something similar. We used a tool that makes an implementation that's very similar to R2 and RML and can actually export to R2RML if you like. It's called OnTop Pro. It's a plugin for Protege. Protege is an environment in which you can edit ontologies, and with this plugin you can specify in this tool mappings between the SQL statements to extract data from a table in the database and map it to a template of RDF triples. So here we're explaining that some truck with an ID, truck ID that's extracted from the table is actually of type truck, and that it has a license number, which is license number, and the fuel level, and that the status is this fed from the column of current activity. Now, in this way, we can specify all the mappings, and then use this tool to extract and convert all the data from the database to RDF. RDF, the data uniform data model for the semantic web. And we're using this OnTop Quest reasoner within Sesame to do that. And this is just some examples of the in turtle format of the kind of triples that you would get. So there's some subject identifier here, then a property name, a relationship, and then a value, or maybe another entity within the data set. So here the truck is related through the owner property to the organization Snells. Once we have converted all the data to RDF, we can now upload it into an RDF triple store. So in our case, it's the Virtuoso open source triple store, but we load the data through ontowiki. And I'll show you in a live demo what this looks like. So here I am in the ontowiki environment. I can log in as administrator of the access point. I can select the database, the Truckers United data set. And what I see here on the left are all the classes that, so the concepts that are used within my data set. For example, the organization class. And when I click on that, I can browse through all the data, everything that's of type organization. And I see here there are 3 organizations within the Truckers United community. I can click through and investigate, for example, this particular organization. Here we see the URI identifying this entity. And this is something that, you know, if you get it, marks, for example, this is the identification of a organization. But if you get the identification of a truck or a container, you can just paste it in your browser and get actually to this very same page here. So there's a way to access data from the access point. And so here we see the drivers belonging to this company and the trucks belonging to this company, etc. Now, so this is a nice interface for, say, the manager of the access point. He can look at what kind of data is in here. He can even change data. So here's the name of the company. We can might be able to edit it, for example, and change it. I won't do that now. But in the iCargo ecosystem, we also want to be able to not only manage data in this browser-like fashion, but we also would like to query it and or expose the data so we can programmatically make access points or other software interact with each other. And this solution provides 2 interfaces: a Sparkle query interface, which is offered out of the box, out of the Virtuoso box. It's the Sparkle endpoint, where you can query it, and there's also a simple REST-style API offered out of the ontology box. Just a quick view of this. So a Sparkle interface. So this is an example of a kind of query that you could fire at this Sparkle access point. This is a query that asks for the trucks and their drivers. If I run the query like this, we see just an HTML page representing the data. We see the trucks and their drivers. But I could also ask, if I was a piece of other software or another access point, I could ask for the data in a more suitable format, for example, in RDF XML or in Turtle format, or in JSON format or XML format or whatever, even just as a CSV file, if you like, to be used in other applications. Okay, so this showed in the demo. This is the REST-style API that we've also shown in the demo. So to summarize, what we have done is created a semantic model and a URI scheme for the Truckers United case. We mapped the database schema to the semantic model using this OnTop tool. We converted the data to RDF. We store the data in an RDF store, and that way make it suitable to manage through a web interface, and also to expose the data in that way to through a Sparkle interface and also an API. And this is just a summary of the used technology for you to review later if you like. Okay. Then for to conclude, I'll pass over to Matthijs.
Yes, thank you, Maarten. So we went through the entire stack, so to speak, from the concept of an access point, from configuring it using an ontology, and then setting up an access point using semantic web technology. So just some conclusions at this stage, and then I'll leave it open to you for a Q&A. First of all, we believe that access points can facilitate the development of intelligent cargo solutions. In general, you connect once and use it many times because it is not limited to one type of solution. And it allows for controlled data sharing in the business community with everybody else that you would like to share data with suppliers, customers, and so on. As indicated, we have three types of access points. The eFreight access point, which is message-based, very traditional. There's the iCargo REST style access point, very suitable, for example, for mobile app development. And today we showed you the semantic web access point, which is benefiting from the technologies from the semantic web and obviously much more flexible to query and to select and to share data. We showed you the logistics core ontology, and we showed you the various use cases that are there to configure the semantics of an access point, so to express the meaning of the data that is available through that particular access point. And we showed you how it can be integrated with your existing systems and databases. Obviously today we focused on the semantic web access point. If you look at the other type of access point, there's obviously a similar use case, and we have additional tools for that, such as, for example, semantic gateways in the project, but that was not the subject of today's presentation. And finally, I think the semantic web access point brings together two worlds. It's the more or less new world of the semantic web and linked data to the world of intelligent cargo developments. And I think it's very promising to see how this will materialize in the years to come, because these are new technologies, but they can provide a lot of functionality that we do not have today. Now finally, if you'd like to have more information about what we showed you today, please visit our website. It's iCargo.eu. There you can find all public deliverables of the iCargo project, not only on this topic, but also on the other aspects of the iCargo projects, such as the logistics innovations that iCargo is bringing, and also the generic solutions that are built within the framework of the project. The demo that was shown by Maarten to set up your own iCargo semantic access point and the tooling required for that, you can find that demo on GitHub with all the installation instructions. So you just have to go to that website. And finally, if you're working with semantic models and want to use the logistics core ontology for that, you can also download that for free at ontology.tno.nl. So with that, I would like to conclude the presentation, and I will open up the section for Q&As now. Okay, thank you, Marianne. So maybe there's one question for you, Laura, that came up earlier also in the mail, because there are, obviously you have LogiCO and you also have all kinds of standards for message exchange. Maybe you can describe how these two relate. When do you use a standard for message exchange, and when do you use LogiCO?
Okay. We have, LogiCO obviously can be directly used with the semantic web standards. So if you have your data in RDF, like Martin showed, then you can directly use LogiCO. You are already in the world of the semantic web, so you just use it. It's the easiest, straightforward way. Otherwise, there are other ways, because a lot is now expressed, for example, in XML messages, as we said. So the point is that XML is not suitable, it's a syntax, so it's not suitable to express semantics, but there are ways to transform XML into RDF So to take basically these messages into the world of the semantic web and LogiCO, and then translate this back to XML messages. So in this case, this means that if you're using XML messages, you can still be using that, and it's possible to provide adapters that will translate these messages into the semantics of LogiCO and back from LogiCO to XML. And this is an example. I don't know if there were other specific examples, but Martin also showed that you can, for example, query RDF and this data and then get back something maybe into JSON. So that's all possible.
Okay. Then, also given the time, maybe the last question from Jacob Forsberg, and maybe Martin, you can answer that one. You showed the use of semantic web technologies. Obviously, that gets a lot of interest from a technology point of view. But can you also indicate the challenges regarding interoperability and semantics, which challenges are solved by using that technology?
Yeah. Yes, of course. So we saw the Truckers United case at the beginning was introduced by Matthijs, that they want to exchange information between the container terminal and the trucking companies. And the trucking companies may have different kinds of systems in which they have their data that they want to share, and obviously also the container terminal have their own systems. And so we're trying to solve here the interoperability problem between these different kinds of systems in a way that's kind of plug and play. So rather than creating dedicated integration solutions, if everybody publishes their data in an access point that's adhering to these kinds of standards and annotating them with their proper semantic models and relating their semantic models to some common ontology like the core ontology, then it becomes easier to kind of plug and play to integrate these different kind of systems.
And probably maybe to add to that, it's not just that it's a solution for this particular case, because obviously you could have chosen a traditional way of integration for that, and a traditional way of looking at semantics. But obviously if you want to do that at a larger scale, connect to other terminals, connect with other truckers and so on, then you can see the benefits of using such an approach. Okay, also given the time, I think this is where we have to conclude our webinar for today. Thank you very much for joining us today. What we will do is we will publish the webinar on the website, as well as the links that were mentioned in the presentation, so you can look at these things yourself. And also, if you have any further follow-up question, or when you would like to get in touch, we will also provide you with the contact details to do so. So for now, thank you very much, and we hope to see you again soon on